Hello, in this video we are going to see the reverse proxy, API gateway and load balancer and how exactly they are leveraged in a microservices architecture. What is the layering of them? So before understanding reverse proxy, let's quickly learn what exactly is a proxy. So one example of proxy is in the classroom wherein there are multiple students and the teacher is taking attendance, and one student requests another student to mark the attendance for him. So when the teacher is asking for a student, let's say Bob, instead of Bob saying present sir, Alice does a proxy for him, and Alice, let's say he's a guy and he says present sir. So here what has happened, Alice has given a proxy for Bob. So that is proxy. Another example which can be seen here is again from the school itself, wherein school internet has a firewall, and this firewall blocks sites which are social sites. So for example, Facebook is blocked. So if you try to access Facebook from the school PC, you won't be able to access because firewall has the rules wherein Facebook is blacklisted. You won't be able to access Facebook. So thereby what you can do is you can access a server URL which is a proxy URL which is not blacklisted here, which is not identified yet to be blacklisted, and you access that proxy server, and inside that proxy server you open the in the browser the proxy URL, and inside the proxy URL you open the Facebook. So thereby you would be able to access the Facebook. So here what is happening is the proxy is essentially helping the client. So this is essentially being leveraged at the client side. So this is very important to understand that when we say proxy or a forward proxy, it is at the client side. That is very important to understand. It is facilitating the client side, not the server side. Reverse proxy is just the opposite. Let's see that. So in case of reverse proxy, what happens? The proxy is at the server side. When you are accessing a site, let's say you are accessing example.com, and from your browser, when you are accessing the example.com, instead of accessing the exact web server from where the pages are being fetched and sent to you, instead of that, you are first directed to the proxy, and this is hidden from you, the exact web server from where the pages are hidden from you. So the server has put a proxy in front of it, whereby it is able to control the traffic which is going to the web server, thereby granting more security to the web server. One important thing to notice here is that this web server is not visible to the outside internet. Only outside internet can only see the proxy, and this proxy, because it is on the server side, it is called reverse proxy. So now you can correlate that the server side proxy is the reverse proxy, and the proxy which helps the client side is the forward proxy, or for simplicity we call it only proxy. Now again, leveraging the same example again, when you are accessing amazon.com, so what essentially happens is you access the Amazon proxy server. Okay, so these are the users. They can access their either from the device, they can access the app or the website, or they can access the website from their laptop, desktop, their machine, and what they see is only the amazon.com website, which is basically the pages which are coming from the proxy server. But inherently, the inside of this, there are lot many things which are there. So inside of this, there may be lot many things which may be there. So for example, so there would be multiple things which would be delivering the goods to the Amazon website. So what would be happening is that there may be a store, the store warehouse, maybe their warehouse may be supplies from multiple factories. So all these things are abstracted. So this is what is proxy. So wherein you just see the amazon.com website, but what is happening on the back end is multiple things which are completely invisible to you. Okay, the processor, the factory, and it's a non-computer example wherein the architecture is basically not there for simplicity, and I'm talking in terms of physical warehouse and everything. But essentially what happens in proxy is there are a lot of components which are there. If we talk about a computer architecture, then there would be servers, there would be processors, there would be cards, there would be a lot of different logic which would be there, which would be completely behind the proxy and you would not be able to access that. So that is basically hidden with the help of proxy. So only proxy is what you see, the rest of things are invisible to you. So it acts as an intermediary between client and backend servers, and backend servers are not visible to you. You can only see the proxy. So what it helps us in? It helps us in security, because these things are not accessible. You cannot harm anything here directly. It helps you to cache things. So things which are repeatedly used can be cached directly at the proxy, and thereby the requests and calls may not be made further on. The cache data can be returned to the client side. Offloading task can handle functionalities like SSL termination. So what is SSL termination? Which means the data from the traffic from here to here is encrypted. Okay, it is basically encrypted with the key. So and at the proxy, the encrypted data is decrypted, and beyond this the traffic can be decrypted traffic, because SSL offloading has been done here. So SSL data which was encrypted with the help of SSL, beyond this, once the decryption has been done, beyond this the data is decrypted. So that is what is SSL termination. So that is what is a reverse proxy. And let's give another example. Let's, instead of calling it a receptionist, let's call it's a call center agent. So you call the call center agent, and many times he or she is not able to answer the question directly. So what he or she does is they will put you on hold, and they will get the information and then reply you the information back. So what they are acting as is a proxy, reverse proxy, wherein they are referring their seniors, they are referring some computers, they are referring some manuals and getting the information for you. In the meantime, they are putting you on hold. So thereby what is happening is you are only aware of the call center agent. You are not aware of how he or she is getting the information. That back channels are hidden from you. That is exactly the purpose of a reverse proxy. Now elaborating that example further, again the same thing, you as a user trying to get into Amazon with your website, with your PDAs, and then there is a processor, and the processor is getting the data from a warehouse, and the warehouse was initially getting the data from one factory. Whatever you needed was being fetched from one factory. Now what happened is the demand suddenly increased. It is a festive season and the demand increased. So then what they do is they are asking, the customers are again and again coming to your site, whereby what you do, you reach out to different factories, more than one factories, and get the data from them. So now what is happening? The load balancing is happening. You are getting the data from different factories and you are able to fulfill the demand of the user. So this is a load balancer. So distributes incoming traffic across multiple servers or microservices, ensures optimal resource utilization, preventing offloading any single server, improves responsiveness. So what would happen is, instead of demand going to again and again to a single server, thereby throttling that server, the demand goes to multiple servers and it improves the responsiveness. So let's again see an example. You must have seen that in international flights, when you are going for your validation of the visa and the stamping of the visa, there is a steward who helps you to direct to a proper line. So there are multiple lines which are there and multiple people who are coming here. So what he will say is he will ask one person to go to this queue, one person to go to this queue, one person to go to this queue. Thereby what he is doing is he is reducing the load which would come to a single person if everybody is getting queued at the same place. So what he or she is doing here is that steward is helping direct the traffic to multiple security officers, and thereby he is acting as a load balancer. Now the API gateway. So API gateway is, we have, let's say, multiple. There is sports goods which we require. There are books which we require. There are, let's say, apparels which we require. So everything cannot be apparels and everything cannot be given by one factory. So we would have different factories responding to different kind of demands which are coming. So how can we know that which demand to route where? That is basically done by the API gateway. So it would route the request in, if we talk about microservices, it would route the request to an appropriate and apt microservice. That is the primary function of it. Let's read it here. Acts as a single entry point for APIs managing access and routing requests to the appropriate microservice. So here what is happening? It is routing the request for a sports good request to this factory, for a book request to this factory. If you want to go for a cloth, apparel, it is going to this factory. So that is what is routing the request to the appropriate microservice. Benefits: provides a centralized point to manage different versions, security policies, and rate limiting. So it can also do rate limiting. For example, if in case lot of book requests are coming per second, let's say 1000 requests are coming, we can throttle and we can say that only 100 requests per second are allowed here for the book factory. So that throttling can be done. That is rate limiting. You can allow policies, security policies can be applied here. You can have different versions of the APIs which could be there. So that is what is being done with API management. It can aggregate the response from multiple microservices and respond together as a single response. That is what is called aggregation. Analytics: it can also do analytics of what kind of APIs are in use, what is the performance, how much time it takes for an API to respond. So all those analytics can also be performed at the API gateway. So how to think of it? We can think of it as a central hub that validates user access, directs API requests and to the relevant microservice behind the scene, and deliver the combined response to the client. Okay, so now let's see in a typical microservice architecture how these things are laid out. So how these are laid out: first point would be a reverse proxy. Then what you would be having? You would be having a API gateway. And then you shall be having load balancers for the individual services. That would be typical, but it can change based on your architectural need. Again, reading the same thing again, the sequence in which the reverse proxy, API gateway and load balancer are typically arranged in microservice architecture can vary depending on specific requirement and design choices. However, a common setup often involves reverse proxy in front of both API gateway and load balancer. So here is a typical sequence: reverse proxy. The reverse proxy is placed outermost layer. Okay, it acts as a initial entry point for incoming client request. API gateway behind the reverse proxy, API gateway serves as the entry point for client requests after they pass through the reverse proxy. And load balancer, positioned behind the API gateway, the load balancer distributes incoming requests across multiple instances of individual microservices.